This is analog input with digital triggering on the National Instruments USB-6211. We'll get into programming this with LabView in just a moment, but first I'd like to describe for you our hardware setup. This is the USB-6211. Here I have a potentiometer that I'm powering with the high side 5-volt output of the 6211. The low side of the potentiometer will come back here to ground, and this middle terminal will vary in voltage as we change the potentiometer position, and it's going to be read right in here in the analog input channel 0. Over here, we're going to do our data acquisition digital triggering with this switch right here. We have a digital trigger input coming through this switch, and that's going to be tied over here back to ground. So when we push this switch, we will ground that input and we'll have a negative going event that will be our digital trigger. But to make sure this is being held high when the button isn't pressed, I've got the 5 volts coming through a pull-up resistor to hold that line high. So let's go into LabView and program this application. We'll go to a blank virtual instrument front panel. I'll click the right mouse button, and I'm going to get a graph and I'm going to put it down on the front panel so we can see the data acquired in real time. Now I know that it goes from 0 to 5 because that's how I'm powering the potentiometer in our setup. So I'm going to scale it from 0 to 5 here. And I'm also going to tell it not to auto scale because I don't want it to change while it's running. And remember, again, that 5 volts is coming from here to our potentiometer, and that's why we scaled this graph right here from 0 to 5. Now I want to put down a second graph. So I'll choose a second graph. I'll stretch it out, and this one's pretty much ready to go, other than I need to tell it to do something called a loose fit, which just means the data will stretch all the way from here to here on my graph. Alright, now what we need to do is go back to the block diagram and program up this application. So I'll click the right mouse button, I'll go into Measurement and I/O, and I'll go down and get my DAC Assistant, and this is going to help me configure my data acquisition tasks. So we'll acquire signals, analog input, and a voltage. And then I want to take it from analog input channel 0, again, which is this input channel right here on our device. And I'll click Finish. What we need to do now is specify some things about this acquisition. I know that my input is referenced single-ended. And it's referenced single-ended because I'm just using one input and then the ground here on my system as the negative side input. I also need to tell it to acquire data continuously so that it runs over and over again and that it is gap-free. Now I'll go into triggering and I'll tell it to do a digital trigger. On our setup over here, this is the digital trigger input, and in our software right here, we've just set that as the digital input. It could be rising or falling edge, and that's our PF0 line right there. So we're all set on that, and then finally, I don't want this to time out while it's waiting for the trigger to happen, so I'll tell it to wait indefinitely and use a -1 to make that happen. So we'll say OK here, and that's going to go and configure this, and we're ready to go. It's going to ask me if we want to put this inside a loop, and the answer is yes, because it's running continuously, and I'd like to see that data displayed on a waveform graph over and over again, so I'll place that inside the loop and I'll wire it up. Next I want to do my data logging, so I'll go into File I/O, and I'll get another assistant that I put inside the loop that's going to ask questions about how I'd like to store this data. So we'll do binary, we'll do one header only, and then we'll do one column per channel, and that's going to set up my data acquisition file write. Well, to actually write the data into that file, I would wire that over, and now it's going to write that data into the file. Make a little bit more room in here so that you can see things just a little bit better. And then finally, we're going to do the read from file. So I'll click the right mouse button. Here's the read from file, and I'll put it outside the loop. It's going to ask me a few more questions, and all I really have to tell it is that this is a binary file. So we'll say OK. And now it's ready to read the data back out. Well, I have to tell it what file to open, so I'll take the file name that's coming out of here, and I'll tell it which file to open up by wiring that in right there. Finally, once it does its read, we would like to see that data, so I'll wire that into our second waveform graph that's on the front panel. So looking at our program, we acquire the data, we can view it while we're acquiring it, we continuously write that gap-free data into a file. Then when we're all done with that, we hit the stop button. It will open that up, it'll read it out, and it'll display our entire data log session on our second waveform graph. So that's set up and ready to go. Before we run, I would like to set the line widths of my graphs to be a bit bigger so that it's more obvious and easier to see in our display here. So we're ready to run this now. I'll hit the run button, and now it's sitting there waiting for me to come in and press the digital trigger. So if I move the potentiometer, you don't see anything happening on the screen because we have not triggered the acquisition yet. But I'm going to come over here and press this digital trigger, and now we're acquiring data. And when I move it, you can see that the waveform moves up and down proportional to the motions that I have on the potentiometer. So if I wait for a minute there, you'll see a flat spot in the data that we're acquiring, and then if I move up and down again, that will help us identify our data set. So at this point, I'm going to come back into our program. I'm going to come down here and I'm going to press this stop button, and what you can see is there's the complete data log session that we acquired and stored off to disk, and then we read it back out. So here's where I was moving the potentiometer up and down. This is where I paused, and this is where I moved it up and down again. So this is an analog input acquisition task with digital triggering, and this is how you get this done with the USB 6211.